Science question 33. The graph below shows for sound waves of three different frequencies how this symbol right here varies with relative humidity and air at a particular temperature. Okay, so this symbol right here, even if we haven't seen a ton of it, in the ACT Science section, if you need it, most likely it will be explained somewhere in the passage. So right here, the attenuation coefficient, and there's that symbol. And if there's anything else that is a little unfamiliar, for example, this right here, in this situation, it's decimals per kilometer. That's what that symbol represents. Okay, they want to know that if there's something that's unfamiliar or unknown, are you willing to push through it and can you still make connections even if you don't know it initially? Okay, all right, so let's kind of clear that out. Oh, I thought it was the eraser. Okay, so let's take a look at our graph and just identify some of the variables in this question 33. So we have this decibels per kilometer, right? We have relative humidity with percents, and then we have hertz. Okay, that sounds good. Now, what do they want to know? So starting right here, based on figure 1, the particular air temperature is most likely which of the following? So in the passage, we have figure 2 and we have figure 1, and I'm going to zoom in on figure 1. And let's see, what does figure 1 and the graph in 33 have in common? Okay, so I'm going to, right here, it has the same thing right here, this decimals per kilometer. It has hertz, and it has the 1,500 and 200, just like that one. And then the difference that I'm seeing is that this guy has the temperature, while the other one has this percent humidity here on the bottom. Okay, so it wants to know that based on this figure in 33, so right here, based on figure 1, the particular air temperature is most likely which of the following? Let's just see. So temperature, option A is going to be -20. And then we have 0 degrees Celsius, 20 degrees Celsius, or 100. Those are the options A, B, C, or D. Okay, and so if I were to capture what's happening here in 33, right here, at what temperature in figure 1 is it most likely to be? Okay, so when I look at -20, do you see how they're all together? Okay, do you see how they're all together? I know that that's not going to be it because you can see that these are all very distinct and spread out. So it's not going to be that one. And in fact, I'm going to just take a little minute and identify what these points are and see if that will help me. Okay, so I've got, what is that, 12, that's 14 right here. We've got 9 and we've got 3. That's kind of the spread. And so if I look over at 14, here's a 14 right here, and that's at 0. There's also a 14 at 20, so it could be 20, but I don't see it on 100. So it's probably not going to be this 100. So we've been able to eliminate 2. Then we have 9 right there. Here's a 9. And then there's also some other 9s with the other, like here's a 9, but that's not one of the options here. So 0 is looking pretty good. And then we have a 3, and here's, yeah, for sure. Do you see how this all lines up? It's very possible. It's most likely, right? That's kind of the fun for this kind of problem. Most likely that this graph right here is capturing, this graph right here is capturing what's happening at 0 degrees Celsius with that, comparing this with figure 1. So the answer to 33 is B.